Hi everyone, my name is Mario Vuksan, and I'm one of the founders of Reversing Labs. Here's Tomislav Pericin, who is another founder of Reversing Labs and another team member of ours, Marius Vajac. And we are a company that pretty much works on reversing tools and produces both open source, free, and closed source components. And today we are here to talk about a new open source project that is going to be very accessible and very useful to really wide audience of both researchers and companies, and it's called TitanMist. Our goal for this tool for over the next several years is really to be part of your daily life, and as we want to call it, something that's going to bring the peace, or some sort of calm, to your reversing activities. Anyhow, so let me just, give you a sense of what we're going to talk about in what order. For one, we definitely want to explain why, we wanted to put together TitanMist, what sort of the problems it's trying to solve, and really its effect on the what we call human aspect of the security industry. All the issues and problems and things we are dealing, and how hopefully TitanMist will be able to make some difference. After that, we're going to really go deeper into the dynamic analysis, unpacking file formats, and give you a thorough overview of TitanMist, what sort of infrastructure it requires, what it takes to modify it, its code base, and obviously collaborative parts that this project is all about. And then finally, we're going to look at our knowledge base of file formats that are intrinsic part of this project. So anyhow, let me just bore you for a few minutes about the sort of high-level motivations behind us. And it really sort of boils down to the individual that's operating in various facets of security today, doing malware analysis, reverse engineering, and or penetration testing, where obviously skills are paramount element. Nothing you can really learn in a school, be educated. It's really all the stuff that we ourselves had to pick up, and you're never really sure if you really know everything that it takes to deal with the problems at hand. And then obviously at the same time, you want to have toolbox, with you, toolbox of things that can help you complete the job. And when it comes to toolboxes or tools, they generally come up in two very disparate categories. They're either very expensive commercial products, geared towards larger organizations, not really targeted towards smaller researchers, independent analysts, or others, or they're free or open sourced tools that have been produced for a conference or two, maybe they lived for a year and then abandoned. I mean, generally poorly supported. Granted, there are some really notable exceptions, OliDebug and Metasploit being, definitely examples that, we ourselves, want to live up to and, be with TitanMist, for a year and try to have, as many people collaborating for obviously the benefit of everyone else. And when we're really talking about working together, just want to sort of take back and say that industry hasn't really been collaborating on research very much in the past, but with the growing problems, growing numbers of all types, there's more and more researchers, investigators, and especially security companies exchanging data, collaborating, forming various closed or open lists, for shipping data. So, but as that, the number of data sets is growing, so are the sample collections that come in with whatever analysis you have made. And with expanding collections come the problems, so, how do we compare the stuff that I got? So if I worked on Stuxnet and another person worked on that, how do we compare the samples, our notes? What are these samples, where they came from, how do you get a baseline with them? So obviously for anti-malware stuff, it really starts with naming and behavior conventions. old problem, the really bad stuff, which gets only more complicated when you start looking at underlying, packing and protection formats. And then finally, people, when they compare things, start looking at, where did you get this sample? Did you try to unpack it? Is this an unpacking variant? Is it replicated? Did it have run? And then finally, if you send me a report with your collection, really, what did you use to identify the samples with? If you use PID, what set of signatures did you use along with it? There's nothing really standardized. There's really no revision version that we could use just to compare the notes and be able to compare what we have and what we don't have. So hence, it becomes very difficult to really compare the submissions or collaborative data from lots of different resources, because there is no, standard, golden standard on what these things are. And obviously, unpacking is another thing. If you try to unpack it with one of the 800 free scripts or any of the AV tools, it's very difficult, to really compare what version or what has happened depending on the protection methods used by a packer or protector. So, to sort of cut the real, story shorter, we envision TitanMist to be a unified unpacking solution. Because we believe people definitely need better tools. They need tools that are integrated. We really want to put together the PID, lots of all scripts, all sorts of other little tools into one thing that you can download, you can rely on, have a version on it, and a tool that will identify sort of disparate functionalities of format identification, analysis, and then obviously unpacking. And this has to be alternative to commercial solutions, because there's really no guarantee that everybody can have the same commercial solution, be it an AV product or being one of the commercial sandboxes. So it's very important that we have an open, free, and sort of let's say vendor-independent solution. And as such, for example, we are collaborating with the IEEE malware working group, where that organization, for the benefit of the vendor collaboration, will add one more module to TitanMist. It's the format identification library that was developed by Peter Ferry of Microsoft. They're still clearing the licensing issues to release that into public. And we have already asked if we could potentially include this part for the general public, but we do expect that at least to be integrated with TitanMist in the short term, and hopefully given to everybody, not just vendors who participate in an IEEE workgroup. Anyhow, so just a second. Yeah. So the bottom line of this thing is that we have pretty much two sets of goals. One are technological goals, another one are community goals. So we want faster analysis for different use cases, be it malware, cracked software, vulnerable applications. Whether you're interested in removal of obfuscation or building of better heuristic systems, and then obviously we want this thing to be highly accessible. So the full install, not just source code that you have to compile and and deal with, but something that's easily reachable, open, and free. And then on the community side, we want really to have a global open solution, not only for antivirus labs, but also for the general public, that cannot afford specialized and expensive tool sets, but is looking for open and free alternatives, and something that's actually well supported. So we will have forums, knowledge base, and Tomislav will tell you more about it. And the main point being, let's try to have multiple authors around one single distribution that we could agree on as the sort of the reference point in our information exchanges. And then obviously the website itself, is hoping to be one place for different comments and information about the formats and components of TitanMist. All right, so with that, I will pass the baton to Tomislav to give you a deeper dive into TitanMist.
Hello, everyone. Okay, it works now. Hello everyone, my name is Tomislav Pericin. I'm one of the founders of Reversing Labs Corporation, and I'm here today to tell you all the nuts and bolts behind the TitanMist project. So, if you remember from the last year, we were here at the same place and we gave a presentation about the Titan Engine project. And the Titan Engine project is an open source library with about 400 functions that enables you to create your own unpackers. Now, it is the Titan Engine on which this... Okay, sorry. It is the Titan Engine on which this project has been built, and you can basically think about the TitanMist project as the database around the Titan Engine. So that's the basic idea behind the TitanMist. So in the basic introduction, you have the TitanMist it has its own key features, and that's tool for format identification and tool for specific unpacking. So in a way, we created a database that connects both identification and unpacking in a single layer. So all the information about the formats that are currently supported and that are going to be supported is going to be available freely in the public database public knowledge base that we just talked about, and that's going to be a Wikipedia-like website which is online right now, and you can go to our website and check it out. So the idea behind the project is that the project itself is easily extendable and community supported. And of course, since we added an update feature to the TitanMist project is always up to date, so you're always up to date with your signatures and unpackers directly from our website. So as people contribute the different solutions to different problems, they will be available as soon as possible. So the infrastructure behind the TitanMist project is really simple. So the TitanMist unifies both identification and unpacking in a single layer, and it has an update feature, and at the back end it has a knowledge base that serves as a reference point for further research. So the knowledge base is just back end information for your research, and just have some samples and whatever you need to conduct your research. So the basic layout of the database is as follows on the screen. So in a nutshell, it's an XML database which has the following features. So for example, it doesn't work.
Can you switch him on the regular mic?
Yeah, because this.
Because it's like, you know.
Yeah.
Yeah.
Okay. Testing.
Yeah. All right.
Okay. So the database looks like this. It's basically an XML file which has all the signatures and all the patterns you need to identify files. So if you look at the sample XML output, it's basically a database of entries. And by entry we mean one or more signatures that connect that entry to a specific format. So you can have signatures, multiple signatures for a single format. So one entry would be, let's say, UPX, and you can have multiple signatures for the UPX file format. And correlated to that, you have unpackers, which you can have multiple types of them, and we're going to talk about that a bit later. And once you have the match, the available unpackers can be called, so the process of unpacking is automatic. You have some other fields that describe the file formats. You have the name of the format, which in the UPX's case would be UPX. You have a URL, which is a link to our website, the knowledge base, and that will hold all the information about the format. You have the version of the format, if that's global, and you can also have a version for each of the signatures. And you have the priority, but we'll talk about that a bit later. And you have the order of the packer. So that's the basic information that's been held in the database at all times. Now you have a default database with the program itself, which is loaded each time you start the TitanMist, or you can create your own database and just use that database as your reference point. Now the identification part is first part of the TitanMist project, and it is very important because since we are building a specific unpacker for a specific file format, we need to know which format it is and know which version it is. So these signatures are laid out in a database, and they can be both simple and complex. They are grouped into entries. So as I said, you can have multiple signatures for a single file format because there are different versions and packers evolve over time. And the detection is either global by the entry, so you have one version for the entry, and you can have specific detection for the signature as well. And the entries are linked to the unpackers, which are called once you tell the TitanMist to unpack the file you're interested in, and they are both linked to the online knowledge base. So when we started coding this project, we asked ourselves, what are the reference points from which we have to start our pattern matching? So we have a couple of these. So we can start the pattern matching from the start of the file, and that can be useful in many situations. We're going to talk about that a bit later as well. And we have the standard identification, which starts from the entry point of the file, which is in the stub. And we also added something that could be useful in the future, and that's pattern matching from the overlay. So those are the basic pattern matching options you have for each of the signatures. So the identification can start from the entry point, and these are the default settings listed. So for the entry point, the default is match a pattern. For the overlay, it's a match a pattern as well. For the beginning of the file, it's also matching. But you also have a switch that enables you to scan the entire file for the selected pattern. Now, since these are the default values, they can be overwritten. So each and every one of these patterns can be switched to seek, which means just search for the pattern from that reference point. Now the simple patterns, if you use PID before, it has the user database which contains lots of these signatures. And the most basic signature type is the one we refer to as the simple one. And it enables you to create a simple pattern that identifies the format. So we can have wildcards, which match any byte in the sequence, or you can have bit masking that either matches the high or the low bit. So for example, if you look at the screen, that's the simple UPX pattern that has wildcards for the both byte and the bit masking options. Now we looked at this and said, okay, this is fine, but we have to improve this if we're going to have more complex patterns that can identify formats better. So to improve this, we first identified the problems. And the problem number one we identified, and if you look at the code, that's basically just a UPX sample, and that's the entry point of the UPX stub. So the highlighted part shows a random number of NOP bytes, which is just an op sled, and for different versions, there are different numbers of these bytes. So in order not to have too many signatures for just UPX, we added a wildcard to our pattern matching, which looks like this. So our complex pattern matching would look like star, then our pattern, and then in the parentheses, you will have the byte which repeats indefinite amount of time. So for the previous sample, that would match NOP or byte value 90 for as long as there are NOPs, and after that it would just continue pattern matching. So this solves a couple of problems. This solves a problem where we have bytes that repeat each other, but we don't know the exact number of repetitions. And this solves the problem of having too long of signatures in our database. So that's the first problem we tried to solve, and that's how you apply it to the previous sample. So the problem number two we saw. The problem number two identifies to the random bytes that can be used as well. So if you look at the highlighted part, that's a jump. And throughout the versions of UPX, that jump can have certain values. So it can increase or decrease in jump length. So in order to have a simple signature that's not just going to be a bit masking for the value of the jump, we added ranges. So if you look at the signature now, there's another piece of it which is highlighted, and it indicates the range in which that particular byte is. So if the range is in between 00 and 7F, that byte is always going to be, that jump is always going to be in the positive direction. So you can indicate that as well. And you can make these rules as you like. Now, this solves a bit more problems, not just jumps. It solves the problem of register permutation as well, because you can select a range in which the registers are present inside the instruction. So you can indicate that as the part of the pattern as well. So another problem that we noticed while working on packers is the problem of that certain code can be there just in certain cases. So for this particular example, and this is UPX as well, and this is a dynamic link library. So the first two instructions that are highlighted are only there if the file is a dynamic link library. So the rest of the signature would apply, which we just written, would apply to this as well, if there weren't for these two instructions in the front. So what we did is we added an optional part of the pattern. So the highlighted part says that only if the entire piece of the pattern is present, that piece of the pattern is valid. So if the piece of the pattern is present, the pattern matching will continue from the byte 60. And if it's not present, the optional part will just be skipped. And this solves all sorts of problems as well. This solves the problem of optional instructions, as we just saw at the entry point, but that can be in either place in the file. And this solves the multiple signatures problem, because now we don't have to have two signatures, one for the DLL and one for the executable for the UPX. Now another problem we saw is, this example is ME packer, and it has a jump at the entry point which leads to the specific location inside the portable executable header, and at the statical address in the header you have the code which is an entire stub for that particular packer. So what we did is we added the following complex pattern which enables you to jump skip. So if we set the pattern matching from the beginning of the file and we match it to the first 2 bytes, which is just an MZ for the header, and we say, okay, jump the certain number of bytes, that would be 152 in the MEW case, so that's hexadecimal, and then we can just continue our pattern matching. So this will compact our signature. We don't have to have 152 hexadecimal decimal wildcards, because there's really no need for this. And this jumping can go either way, so we can jump in either positive or the negative direction, which makes our signatures non-linear in comparison to PID, because PID signatures are linear and they have to have one byte after another, because now we can jump backwards. Those signatures cannot be, they can be non-linear as well. So we can match a certain point of the pattern and then jump back to confirm it or do whatever. So, of course, this also solves many problems. It solves the problem of increasing the size of the byte pattern, and it solves the problem of patterns having to be linear. Now the next problem is also very interesting, and this is PE compact. And as you see at the entry point of PE compact, we have the first layer, and the first layer only does the initialization of the structured exception handler. And you have the string that identifies that as the PE compact following this. Now for the PID, classical PID signature, which just matches the entry point, that signature would be way too short. So that can be spoofed and easily spoofed. So what we said is, wouldn't it be nice if we could just follow the value of move EAX and just continue our pattern matching there, because that's the second level of the packer, and everything we need to have this better kind of pattern matching is right there. So why not do that? This is a combination of the previous feature and this one. So this pattern matching enables identification of PE compact in the first layer. So if you see the bytes until the first highlighted part, that's the first layer. And then we jump back. As I said, we can jump back as well. So we jump back to the beginning of the pattern and we match B8 again and say, okay, follow that D word. And we will end up in the second layer of the pattern of the packer and just continue our pattern matching there. Now this is the way we can have complex patterns which enables us to have better quality pattern matching and be sure that the pattern we have matched is really that signature, because as I said, if we only match the first part, this would be way too short and way too easily spoofed. So this also solves the problem of patterns not being linear, because now you can just follow D words anywhere you want, and you can just continue anywhere you want. And the next problem is related to the previous one, and we said, okay, if we can follow D words, why not follow calls as well? So because this is a nonlinear signature now, we can follow calls and continue our pattern matching inside them. So this is an example of shrink warp. And it has a couple of calls that follow into each other, and we said, why not have a pattern that can identify this? So this is how it looks like. First byte is, of course, the identification for call, that's E8. And the following that is our pattern that indicates that that E8 is actually a call, and it's 5 bytes in length. And the plus means that it's always in the plus direction, so it's jumping down in the code. That's also one of the parameters we check for. So if we have a E8 byte, which is followed by 4 bytes, of course, because that's a call, and it's always, if it's in the plus direction, we can just follow that and continue pattern matching from the first byte inside a call. And as you can see, there are some other calls inside the pattern as well that we just follow. So this also solves problems to the byte patterns not being linear and the problems of having way too big byte patterns as well. So if we were just to have a byte pattern that takes into account all the bytes in between this and the call where it starts, we would have way too big of a pattern. Now the last problem we saw, and this is the problem of sliding pieces of code. Now this is a code which can be located anywhere inside the code, and this is ASPAC, and that particular piece of code does importer construction, so that's a call to get proc address somewhere in there. Yeah, call. Okay, so what we said, okay, there's different versions of ASPAC, and this is never at the static location. So if we have a static signature which is long enough to identify ASPAC, why not have another signature inside it which validates that our unpacker will actually work? So what we did is we added searches to our patterns. So inside a specific range, and you see the highlighted part, so inside the range which goes in the plus direction behind the match pattern, it says if it's inside the range of 300 hexadecimal, and if there's this pattern, then you just continue pattern matching from there, from the point where's the last byte of your match. So if you have a couple of these searches, we can just match if they're all, if we have all the patterns we need to actually unpack this file. So now the identification and unpacking are related, because if this is a single layer packer, which ASPAC is, you can just match those patterns you need for the unpacking to work inside the identification process itself. So you know that your unpacker will work before you actually start the unpacking process. And that's now the part of the identification. So that solves problems as well. That solves the problems of byte pattern not matching, because, as I said, this can be at random positions in the file. And it enables us to embed unpacking patterns inside identification. So last but not least, we recognize the fact that there are some packers out there that can sign the file falsely. So we have this packer, which is called MSRLH, and it has an option of inserting fake signatures for those basic formats such as UPX and FSG. So we said, why not check for these byte patterns first at the top layer, and if we are sure that these signatures are not faked, then we can just check for the regular UPX and be sure that this the match we got isn't a fake one. So you can layer out the signatures in our database by priority, and as I said earlier, that's the thing we're going to talk about. So layering out means that the top priority signatures get scanned first, and you have 3 priority levels. So you can use priority level 3 for the ones that creates fake signatures. So this particular format that creates fake signatures will have the top priority, and the UPX would have the least priority, so priority number 1, or you just don't use priority inside the databases at all, and that will be the lowest priority. So what are our future plans for this? We can extend these pattern matching even better. We can say, okay, some packers cannot pack dynamic link libraries, some packers cannot pack 64-bit files, some packers cannot pack .NET files. So if your input file is one of those and your packer doesn't support it, then you really don't have to match that pattern to that particular packer, because it cannot be matched, because that packer cannot pack those kind of files. And we can also filter the files by the import table content. So we know that specific packers such as FSG and packers like that have specific imports that they always import. So for example, most of them just imports kernel 32 with a couple of imports from there. So if we say, okay, Just check for the import table as well as a part of validation process of our pattern matching. Just check if those imports are there. If they are there, then we are correct. And we can also combine our patterns with logic. So we can have AND or in between our patterns. So that can give us more power to have better pattern matching, because we can have multiple conditions that apply to the same signature. So in comparison to the PID, here is the comparison just between the identification parts between the TitanMist and the PID. Of course, this only relates to the user database, because PID is a program, it has its own internal database which has its own rules. So it's far more complex than the user database user can actually extend. So we are just comparing the databases. So for the TitanMist, you can have complex patterns, and for the PID, you can only have the simple ones, which are just wildcards and bit masking. For the PID, you have only single direction patterns, and for the TitanMist, as we saw, we can go either direction, we can follow calls or do anything. Now, for the PID, we only have one starting point, that's the original entry point, and we can follow, and we can search for our patterns anywhere in the file. But we said that's not good enough, because files can be big in size and we don't want to waste our time scanning the entire file. That's why we added more starting points for our signatures. So we can either seek or match patterns with the TitanMist. We have variable byte patterns. We can skip some bytes. We have optional patterns. We can follow the code flow, and we have signature priority. So that's the difference between our project and what's publicly available now. So of course, that was the identification part. TitanMist also has embedded unpackers in there. So the TitanMist unpackers are automated. That means no user interference whatsoever. So you don't have to click around, follow, just input some fields or whatever. The unpackers are automatic. So they can be written in any kind of language. So they can be written in C, C++, Microsoft Assembler, Delphi, Lua, Python, and TitanScript. So this only refers to the unpackers that are written based on the Titan engine. Because you can plug in any kind of unpacker to this kind of project, you can write the unpacker in any kind of programming language or any kind of framework. But since we created the Titan engine, we based our project on top of that. Now the TitanScript is our version of OlliScript. Now OlliScript is a very popular tool with reverse engineers. We know about 800 different scripts that do unpacking for different kind of formats. Have some duplications of course, but there's obviously a good user base for that. And that's why we added the support for that as well. Now the difference between the TitanScript and the OlliScript is that the TitanScript runs inside the Titan engine. So it's based on our automated unpacking tools, and it also enables you to use all of the Titan engine features directly from the script language. So you can use you can easily write unpackers with the TitanScript if you know the Titan engine. Or if you don't, you can use the OlliScript instructions, and we're going to see how we can convert one of those unpackers easily from the OlliScript to TitanScript. Now here is how TitanMist unpackers look like. You have native ones, which can be both static and dynamic in nature. It depends on the unpacker itself. You can have the script unpackers, that's Python, Lua, and TitanScript, Python and Lua, and they can be both static and dynamic. It depends on your coding style. And for the TitanScript, they are only dynamic unpackers, because OlliScript was created to be assistance during manual analysis of the file. So once you load the file in Olli, you start the OlliScript, and it will get you to the entry point. That's why with the TitanScript, you can only write dynamic unpackers. Now currently there's no DLL support, but with the next release there will be one. So how do you create unpackers? You can create both static and dynamic unpackers, as I said, but the process of creating them has the same steps as the manual analysis, which is debugging the file till the entry point, dumping that memory to disk, collecting all the data you need for import and relocation reconstruction, and then you apply custom fixes for all of the protection options that are available today, such as cold splices, entry point obfuscations, stolen entry points, and whatever the protection options are available inside the format you are unpacking. So the static unpacking also has the same steps. You always must decrypt or decompress the memory content and then reconstruct the import table and the original entry point. Now that's all up to unpackers. Whoever writes the unpackers have to deal with all of this. But there are some shortcuts. We're going to talk about that. So if you are familiar with this slide, it's because this slide is from the last year's Titan engine, and this describes how you write unpackers, dynamic unpackers with the Titan engine. So what you do is you read the data from the file, and then you initialize the debugging process, setting some breakpoints, which collect all the data about import fixing, relocation fixing, and at the end entry point as the final breakpoint, which finalizes the unpacking process. So for import data gathering, you would place a breakpoint on the pieces of code inside the packer, which calls load library to load a new dynamic link libraries needed by the packed file. So once you are there, you collect the data, and that's just the string, the name of the dynamic link library which is being loaded. That information is passed to the Titan engine, its importer module, which uses that to reconstruct the import table later. So the same goes for the getProc address, which is the function inside Windows, which finds the functions inside the loaded libraries. So that information as well is passed to the Titan engine, which at the entry point, at the final point of unpacking the file, reconstructs everything by using that data you collected. Same goes for relocations. Now there's a shortcut, because relocations can be tricky to fix. We created a shortcut, which is just creating two snapshots. One before the actual relocations occur, and one just after relocation occurs. So once we compare two snapshots, we get a valid relocation table, and that's an easy way to fix dynamic link libraries, which when they have a valid relocation table, they can be loaded on different image bases, and that means that they're valid files for later on analysis. So at the entry point, this is the final step, we have to dump the process to disk, and of course we can use an option to recover the damaged PE header if you like. That goes before the process dumping. And after that we just add a couple of sections, one for the import address table and one for the relocations, after which the file is valid on the disk, but we still need to realign it, which makes it as compact as possible and makes sure that all the sections are in the right place. So once we finish that, we just stop the debugging process because we are done. So that's the whole philosophy, and it's pretty easy steps into unpacking anything with the Titan engine. Now, as we said, you can create native unpackers, and I just talked about how you can use the Titan engine to do this, but you can also create script unpackers as well. And to create script unpackers, you can use TitanScript. Now, TitanScript, as we said, is our version of OllyDBG script, so it has the same syntax, but it also enables you to use the existing Titan engine functions. Now, all these scripts that are existing in the wild, as I said, there are 700 different or 800 different scripts we know about. You can easily reuse them, but you can either recode them or add some instructions to them to make them a valid automated unpacker, because all these scripts are not full-blown unpackers. They will only fix the file and get you to the entry point. At that particular time, you have to dump the memory yourself and fix the import table with additional tools. Now, the Titan script enables you to create automated unpackers, so those scripts are full-blown unpackers. Now, as I said, we can either recode all these scripts to match the Titan engine layout, or we can add a couple of instructions. Now, first instruction we can add, and this is really easy, is called dump and fix. So it does what it says. Once you're at the entry point with your script, you just dump and fix the file to disk, and that's all you do. And if there are some errors during unpacking, because this is an automated tool and it needs to know if your actual unpacking has succeeded or not, you can just say, okay, error, this unpacker didn't work. So here is an example of the script. The left one is Olly script and the right one is TitanScript, and there's just one instruction we added. And this script is a UPX example, so what this script does in way too many lines of code is it finds the pop-add at the end of the UPX stub, places a hardware breakpoint there. Once it breaks, it clears it, and then steps over that, and it's at the entry point. Now, the Titan script that would do the same thing is exactly the same as this one. So since we are converting all the script to Titan script, we just need to add one instruction. So once we are at the entry point, just before return the end of the script, we just say dump and fix, and that particular script will be executed till that point, and once you're at the entry point, everything from memory will be dumped to disk and fixed by the Titan engine, TitanMist. So since all of the unpacking we do is either static or dynamic, but we want to rely on dynamic unpacking more because it's a more resilient form of unpacking, that yields a couple of problems. That yields a problem of damaged and broken files that cannot be unpacked because they cannot be started in Windows. We're going to show that a bit later. So we also have problems with files that have missing dependencies, which cannot be unpacked. So if you have a file which is loading a file which dynamic link library which isn't on your system, if you are to unpack that file dynamically, you cannot do that because Windows cannot find it. And there's a problem with some packers which are not data execution protection compatible, so those cannot be unpacked as well. That goes for the packers that store their code inside the portable executable headers, so that's FSG, and there are more examples of this. But there's some good news. There's a solution to all of these problems. We can repair the damaged files, and we can simulate the missing dependencies, so the system thinks that the files are there, so it only gets us through the packing layer, and that's all we are interested in. Once we see the code, we can analyze it further, and if we are into malware analysis, you can determine if the file is malicious or not. And we can just work around data execution prevention or disable it totally. Now, with the Titan engine, if you follow our blog, we did some series of blogs that describe how we created this plugin, which counters all of these problems of dynamical analysis or dynamic unpacking. So we included this inside the TitanMist project. So if you come across a file which is damaged or broken, you can just use this plugin automatically to unpack the files which other ways cannot be unpacked. Now, the Nexus plugin fixes broken files because validation is a crucial point for any kind of unpacking, especially dynamic unpacking. So before any dynamic unpacking is performed, you really want to do validation. And validation will tell you if the files are broken, and if they are broken, if they can be fixed. Now, as I said, Nexus plugin is included with the TitanMist, and all of this validation and repair is done automatically. Now, the Nexus also solves the problem of missing dependencies. Now, some files load dynamic link libraries through the import table, so those files cannot be started at all, while others can load dynamic link libraries on the runtime, and some of them can actually get through the packing layer automatically. So FSG, for example, if it doesn't find the dynamic link library, it will just continue running, and that's bad because the programs can crash if they're packed with that kind of packer. Others are better at this, and when they don't find the library, they just exit. So to counter this, we can fake the presence of dynamic link libraries both statically on disk, just by creating the files so they are physically there and they have all the exports that are needed by the application. Or we can just hook some functions inside the packed process and return fake values to tell the packer that the necessary dynamic link library and the functions are actually there. So we can do either of those, but the Nexus does both of those because there are different models for different packers, and we want to support everything. Now that brings us to our demo. Now we're going to show the demo, and we're going to show how the TitanMist works. We gave our sacrifice to the demo gods, so I'm hoping they're not going to abandon us now. So we have some samples there. Have one file which is broken. We have files that are packed with different kind of packers, which we have Alex Protector, we have ASPack, we have EXEFog, we have TLock, we have Yoda Crypter, we have Unpack, UPX, and we have some other settings with the UPX as well. So this file, for example, and I just talked about the Nexus plugin, this file, for example, doesn't load because it has missing dynamic link libraries, and we can just see that if we place a breakpoint at the load library call and just see how it works. So the first one, kernel, is found, and then we just scroll till we found the one which is missing. So that's going to be 0 and it ends. So we can unpack that file with the help of the Nexus plugin. So this is the TitanMist. It's a console application that you can call with certain parameters. First one is the input parameter, which tells it which file you want to analyze. So if you just start the TitanMist and say, okay, just scan a file, have samples, and we can scan any of these files and say just match. It will give you the information about the file format. So it will give you the name of the file format, which is in this case exe fog. It will give you the version, so the exact version, and it will give you the author of the packer. It will also give you a link to our website which you can follow and on which there's some additional information about this format. So you'll have the information that's available here. You also have protection options that's inside the packer as well. And you'll have some samples and additional unpackers you can use. Now, if we were to unpack the file, we would just call the same, we would just call TitanMist and say, okay, just output this to a file for me, and it will show you a log of what just happened. So since this is a dynamic unpacker, it will log all the information it collected during runtime. So for example, it will show you the dynamic link libraries which the packer is loading. It will show you the functions that are required and the addresses where they are going to be written. And at the end, it's going to tell you the entry point. So once this is done, the output file is the valid portable executable file, which you can just run because it's valid, and you can just analyze it further, and because all of the packing layers have been stripped. So if you look at this is just a simple Visual C++ application. You can analyze further if you like. So we can do the same thing for all sorts of formats, as I said. Some of these unpackers which are linked with the signatures are dynamic and some are static. So we can just test one of these which works as the Titan script. So that would be aspect, for example. So aspect, we do the identification. It tells us it's aspect, tells us who wrote it, and we can go to the website as well. So we can just tell it to unpack itself, and it will load the Titan script. Now, the Titan script, this particular one doesn't have any logging, but you can use that as well. The unpacking succeeded, and we can just open that application as well again and analyze it further. It's the same file, so that's why the entry point looks the same. We can do that as well for the TLOC. For the TLOC, we have a native dynamic unpacker, yes. So TLOC, this is it. Wrong parameter. So identification, it gives us that it's a TLOC. You can go to our website to read more about it, or you can just unpack it normally. So out.exe. And it works. It's a different application. This is the Delphi application. Now, we can do the same for dynamic link libraries as well. So all the files we have unpacked just now have been executables. And we can do the same for the dynamic link libraries. Now, there's a small trick you can use. Now, if you can look at this, this is the UPX file. Now, the default unpacker for UPX is TitanScript. Now, since TitanScript doesn't support unpacking of dynamic link libraries yet, you can just say output this to output DLL, but use the Lua unpacker, which is also available. Now, that will load the Lua framework, and the Lua will unpack this file entirely, because the Lua unpacker relies on the Titan engine, and it both supports executables and dynamic link libraries. Now, if we do that, we output some information, and the output file will be provided, and it's also a valid executable. You can just, it's dynamic link library, written in Delphi as well, which you can analyze further. Now, if you don't know that this unpacker doesn't work with the Titan script, you can just tell it to try all the unpackers which are listed for the specified format. And we do this as fswitch, which is force. So it will try the unpackers in a row until it finds one which is provided in the database which works. So it started the Titan script first, it saw it didn't work, and then it started the Lua automatically, which provides an output file. So we have, as I said, we have the update feature as well. So if we just call the TitanMist with the updates switch, it will connect to our website, download the new database, and it will download all the new unpackers as well with it. So the last thing we have to show for the TitanMist demo is the use of the Nexus plugin. So we have a broken file which doesn't work. If I just start it, so it is broken. So if we just start our TitanMist and say broken is the input file, and we tell it to output it to the output.exe, it will not work. It says unpacking failed because the file is broken. But if we tell it to start it and use the Nexus plugin, that's the end switch, it will automatically repair the file on the disk, and it will monitor the application for the missing dynamic link libraries as well. So if you just start it, it will tell you that the unpacking has succeeded, and the output file is, of course, yet again, the valid portable executable, which you can start the debugger or normally and analyze. So you can try that. And to make sure that the reason why this is failing is because the application is broken, we've included the file, the application called PE-validate. And PE-validate will just scan the application and tell you all about it. If it's valid, it will say it's valid, and if it's not valid, it will give you a detailed report why this is broken. Okay. So demagogues that didn't listen to me, it says the file is valid as well. Okay. And that's the Nexus plugin. It will repair the damaged files. Yeah, because the file has been repaired. So if we just restore that, then it will say why it is broken. Of course. Or not. Doesn't matter. It does work. So the problem we address with this is the damaged files, and we also have files which are missing dynamic link libraries. So this particular file is missing a dynamic link library, which is realign.dll, and this is why it cannot start. So we can use Nexus again and just tell it to unpack the file, which is called xplister. Just output it to output.exe and tell it to use the Nexus plugin. And it will unpack it entirely, because you see it created additional file on the system, which just spoofs the packer into thinking it is there. So the output file as well needs that import as well. You can see that realign is in the import table as well, but the file has been unpacked. You can just load it inside the debugger or disassembler or whatever. If I move it here, then sure it should work. It won't, but you can disassemble it as well. So yes, you can do all sorts of things with the TitanMist, and I believe we showed you everything that the TitanMist can do. For now, that's the demo. For every entry in the database, and you can look at the database once you download the tool, you have a link to our website which gives you an information about the file formats. You have basic information, you have extensive format analysis, which tells you how the format really works, gives you the protection options, gives you a TitanMist unpacker for that, and it gives you some sample files as well. Now we're going to release this tool, and we're going to release it with the support for these 20 formats. So we have some native unpackers. Most of them work statically. Some of them work dynamically, such as TE-lock. And we have some script unpackers, and that script unpackers, which are listed, only refer to the Titan script unpackers. We included 10 of them, so you can just look at them and see how the Titan script really works, because we want Titan script to be one of the key features of this product, and you can heavily rely on it because those unpackers are really easy to write. And we can show you one right now. So unpackers, as I said, you can have Lua, native, or Python, or Titan script. They are all linked to our database, which looks like this. So here's the database, and as I said, it's an XML file. And for the UPX, as you can see, you have three unpackers. One is the Titan script, one is Python, and one is Lua. You can use either of those, and as you see, the default one is set to the Titan script. These are the signatures we created for these formats. 20 different packer families are supported for both identification and unpacking. And you can also have signatures inside this database that only refer to identification. So you don't have to have an unpacker. You can only use this. You can use this for both unpacking and identification, but you can also use it just for identifying purposes. So as you can see, these are the complex signatures we talked about. And for the unpackers, you can have Lua, native Python or Titan script. And for the Titan script, we're just going to load one of those and show how it works. So it does look like Titan engine because, as I said, we recoded this to fit the Titan engine profile and use some Titan engine features such as reading the data from the file, then use the OliScript functions to find the patterns inside a file and place some breakpoints there. So once you place a breakpoint, for example, at the load library, you would read the string which is held at EAX there, and that's the name of the library, and you just pass that to the Titan engine. Same goes for the getProc address. Just read the string or the ordinal number and pass that to the engine. And at the end, you have a static part of the script, which will probably never change. All this does is dumps the file to disk, exports the import table to it, and makes it a valid file. So this is the part of the script which will probably never change for any of the scripts. And of course, if there's an error, you just return error. So that's how one of the unpackers for the Titan scripts looks like. As I said, we shipped 20 of those today. There are no version numbers. We support almost every version of every packer, but for the easy ones such as FSG and I believe ASPAC, we've intentionally left some older versions unsupported because we want the community to start with something easy, so they can just extend the existing framework from that starting point. And that's it for the TitanMist project. Some questions? Yeah, well, as you heard just now, the TitanMist project is a database, and you can extend that. So if you come across something that we don't support yet, you can easily add a signature for that and create an unpacker. We can just mail us a sample, and we'll happily take a look at it. If it's something of interest, we can add that ourselves.
So if there's no signature, then it won't be able to...
Of course, this isn't a generic unpacker. So this isn't a one-click solution. We wanted to contribute. We wanted to have community contributing to this because we know that there are talented reverse engineers all over the world which are happy to work at this. We know of the existence of 800 scripts, and these guys have been working over the past few years on this. So this is a community project which has targeted unpacking. This isn't generic solution because we can't really rely on generic solutions to handle each and every one of those cases. That's why the targeted one is the way to go. Anybody else? Yes?
Have you done much performance testing, for instance, have you looked at the differences in different types of unpacked scripts that you've written and compared it with this commercially available thing or with your own number?
Yeah, well, we did some performance testing for our last presentation. That was Caro Workshop in Helsinki, and the numbers we came up with, and these are pretty accurate, is for dynamic unpacking it takes about 250 milliseconds. That's a round number about for the files for under 1 megabyte to be unpacked, and that's as fast as they are executing. So there's little to none performance penalty for dynamic unpackers. For the static ones, they can go even faster because the only penalty they have is the speed of the algorithm for the decompression, but that's also for the packer. So static ones can go faster than the actual execution. It depends on the file format, of course. Yes?
Will you handle, like structured exception handling for a packer begins to change exception handling?
Okay, yeah, well, the Titan engine can handle all of that. It just depends on how you create your unpacker. So all of the exceptions that are thrown at you are handled by the Titan engine. That doesn't matter. But if there are some protection options, and you're referring to that as well, you can handle that yourself. It depends on the file format. So because you are writing the unpacker for the format, you have to reverse engineer it and counter everything it throws at you. But it has built-in functions to hide the debugger and do the standard stuff we do today. So back to you.
You have coverage on Tomida and Protect and other virtualized packers?
Well, if you write an unpacker for that, we'll be happy to include it.
I mean, are they currently in your database?
No, as I said, we have 20 formats, and those are it. And you know, Tomida is a pretty complex unpacker. If we just gave that free, people would use this tool to break intellectual property, which is protected by Tomida, and we really don't want to do that. So if in your lab you can create your unpacker for Tomida and use it, we do that as well. Anybody else? Yes, you?
There are some packers out there that will unpack the code into a separate process, like
Okay.
PDScript or run PDScript
Yeah.
support for that kind of thing.
Yes, the Titan engine supports multiple unpacking instances, so you can just detach those processes and continue unpacking that process. As I said, it depends on how you create your own unpacker. This isn't a one-click solution. So for the Titan script, it only supports single process unpackers, but there's about 200 packer families which can be supported by this, so I'm thinking this is good enough. And for the rest, you can just write your own native unpacker, which will easily be plugged into the system. Anybody else? It's you?
Does Titan also support unpacking of data that is not really part of the PM that's unpacks it in the kit, unpacks it in the stock, you can still get them?
Yeah, the Titan engine has some functions in it which enable statical decompression. So if there are some known statical compressions such as zlib, I think, and applib and lzma that's supported by the engine, you can just give it a pointer and it will decompress that memory for you, and then you do what you want with it. Yes?
You're trying to build a community around this, or is there some forum or something?
Yes, the forum is on our website, and we will create a much better Q&A kind of website in the days to follow, so we can ask questions and have them answered faster. So if you think of Stack Overflow and websites like that, it's going to be like that, because that's easier to monitor QA. Anybody else?
Have you already reached out to any prevailing organizations that have a number of years of experience in this effort to really kickstart that community effort at this point?
Well, reverse engineering community is quite large, and most of them already follow what we do since last year when we did the Titan engine project, and they are happy to see what we do today. We also have some people that are creating their own unpacking tools, which are similar to TitanMist, based on the Titan engine framework as well. Anybody else? If not, that's all we have. Thank you.